After evaluation of baseball teams, it was determined that more home runs are hit to the right or left rather than down the middle.
Taking this into account, we created a baseball field in which home run hitting is maximized.
First, we started with a square. We wanted the distance between the home plate and the foul poles to be 300 feet.
To maximize home run potential, we moved the fence forward to 400 feet. This makes center home runs more accessible while promoting the already greatly scored side home runs.
This is how we did it. In a square, every angle is a right angle, and drawing a line from foul pole to foul pole, we created a diagonal for the square. This creates a right triangle.
To find the diagonal, we implemented the Pythagorean theorem with 300 as both the A and B term. We found C to be 424 feet.
Because diagonals are equal in a square, the vertical diagonal is also 424 feet.
The distance we want from home to the fence is 400 feet, leaving 24 more feet until the corner of the square. With this, we can calculate the horizontal center fence.
The top of the triangle has an angle of 90 degrees because it has been the angle of the corner of the square. We can create a perpendicular bisector, which is the 24 feet left over from the diagonal. Because the diagonal bisects the angle, there are 45 degrees on both sides. Since there are 180 degrees in a triangle, the remaining angle is also 45 degrees. Using this information, we can determine the length of half of the central fence.
By multiplying 24 and 2, we get the full length of the central fence, which is 48 feet.
To calculate the length of the diagonal fences, x needs to be found. Using Pythagorean theorem, we can find this value. It turns out to be 34 feet.
With the value of 34, we can subtract that from the total side of 300 to get the length of the diagonal fences. This value is 266 feet for each fence. We add all of our values together next to get the total length of the fence to be 580 feet.
Our method for the fence is also very cost-effective. It would cost less than $5,000. While this may seem like a lot of money, remember that this fence will be in use for many, many years to come. One website that we found, called yourfencestore.com, had an option where you could pick the color of your fence. Since our school colors are red and black, we would be able to have a red fence. This red chain link fence would cost approximately $7 a foot, for a total of just over $4,100. In addition, we would need tubing for the top of the fence. This is used to prevent injuries and keep the top safe. This tubing is traditionally in yellow, however, it can also come in black, another one of our school's colors. The tubing comes in groups of 100 feet and 250 feet, so we would have to buy 2 of the 250 feet and 1 of the 100 feet. This adds up to a total of just under $400. In order to install the tubing, you would also need an installation tool that is just over $50. In order to keep the tubing in place, you also need many zip ties. One zip tie is needed for approximately 5 feet of fence, so we would need approximately 116 zip ties. However, zip ties come in groups of 100, so we'd have to buy 2 groups of them. On the bright side, if we ever need zip ties, we'll have a lot to spare. The fence could also be installed by members of our faculty, so we would not need to pay an installation company for this. All of these expenses bring the total for the fence to $4,609.20. This money could easily be raised by fundraisers such as candy selling or allowing companies to advertise on the fence. You should choose our fence for not only the benefit of the baseball team, but the benefit of the entire school. Thank you.